identifying fractions which give terminating and recurring decimals. In other words, can we see some sort of pattern, some sort of reason as to why some fractions become terminating decimals and some become recurring decimals? Now, I usually let my class use the calculator in class when we do this exercise. So let's walk our way through it. So we've got a fraction here of a half. The prime factors in the denominator, well, just 2. Decimal representation of a half is 0.5, which means that it terminates. If we look at a third, 3 is a prime, so that's the prime factor in the denominator. And we know that it's 0.3 recurring. We've come across this one before. If not, just put it on the calculator. A quarter, well, 4 is 2 times 2. So the prime factors in the denominator are just 2. This one is 0.25, and so it terminates. 1/5, well, 5 is a prime. So 5, the fifth is 0.2, and so that terminates. Now 1/7, I think we saw that in the last exercise. Well, 7 is a prime number. I'm just going to go back just briefly and look at the line above. We had 6 here, and so the prime factors are 2 and 3. 2 times 3 is 6. We know that this one is the 0.142, I think it's 857, but in any case, it's recurring. 1/8, well, 8 is 2 times 2 times 2, so the prime factor in the denominator there is 2. The decimal representation is 0.125, and so it terminates. 1/9, 9 is 3 times 3, so the prime factor in the denominator is 3. And we know that that one is 0.1 recurring, which is, of course, recurring. If we look at 10, 10 is 2 times 5, so the primes there are 2 and 5. That's just 0.1, which terminates. 1/11, well, 11 is prime. So if I just do 1 divided by 11 here, it's 0.090909. Don't worry about this one at the end. The calculator rounds at the end of the display. So it is 0.09 recurring, which is recurring. 12 is 2 times 2 times 3, so 2 and 3 are the primes. And we came across this one in an example just now. It's 0.083 recurring, which means it recurs. 13 is a prime here. If I do 1 divided by 13, it's 0.076923, and then it recurs again. So 0.076 923. All of that recurs, so that's recurring. 20 is 4 times 5, which is 2 times 2 times 5, so just 2's and 5's there. And 1/20th is 0.05, so that's terminating. For 25, 25 is 5 times 5, so there's just a 5 there. And that one is 0.04, so that terminates. Now, 1/30, so what have we got there? 2, 3, and 5. And 1/30th is 0.03 recurring. So that recurs. Now if we think about 40, 40 is 8 times 5, so the primes there are 2 and 5. And 1/40, so let's just quickly do 1 divided by 40. 0.025. I should have got that just by halving this one. And that terminates. And then for 50, 50 is 2 times 25, 2 times 5 times 5, and that is 0.02. And so that terminates. Now, what we're going to go on and look at, if we look at all the ones that have 2 or 5, or just 2s and 5s, so all of those ones, what happens? They all terminate. So terminate, terminate, terminate. But the very second that we have another prime, not 2 or 5, we get recurrence. And that holds in general. If a denominator is just some combination of 2s and 5s, we get a terminating decimal. The second that we have some other prime present, we get recurrence.